In this video, we will be talking about some of the abdominal organs and contents. So the first of which I want to show you is the diaphragm. And in this case, we can see, if I hold the diaphragm up, that it's made up of muscular and tendinous portions. The muscular part can be further divided into lumbar regions, costal region, and sternal region, which is a little butchered in this particular one. So this is the diaphragm of a dog. We can see the same idea here in a cat. Muscular, tendinous, lumbar, costal, and sternal. The tendinous part in the middle is called the central tendon. There are 3 holes or openings that go through the diaphragm. And just to orient you, here we're looking dorsally, and this would be ventrally. So this vessel coming through the aortic hiatus would be the aorta. Also going through there would be the thoracic duct and the azygous vein, each of which we only have one of. Going through the esophageal hiatus is the esophagus, as well as the dorsal and ventral vagal trunks. By the time the vagus nerve divides into its branches, which come together to form the trunks, it is the 2 trunks running dorsal and ventral to the esophagus, going through the esophageal hiatus into the abdomen, where they are going to supply parasympathetic innervation to our abdominal contents. The esophageal hiatus is actually located in the right crus of the diaphragm. So it is not simply that one is right and one is left. The right crus is much larger. So the esophageal hiatus goes through the right crus. The aortic hiatus is between the right and the left. The third hole or opening into the diaphragm, or through the diaphragm, would be the opening for the caudal vena cava, and that is called the caval foramen. And it, as you can see, is located within the central tendon. Let's now look on the other side of the diaphragm. And here we're looking in a cat. And this is where the liver is going to be located. So I'm going to turn this around just to make it a little bit more like you would be looking at it in the cadaver. So this is going to be ventral, and my hand would be located dorsal. And we can see the different liver lobes. All animal species have 4 lobes to the liver, some of which are divided. So there is a right lobe, a left lobe, caudate, and quadrate lobes. I always start off by finding this caudate process of the caudate lobe of the liver, because it has a little divot here, which is the impression for the right kidney, or the renal impression. And if we cross over to this lesser omentum, or underneath that lesser omentum, this little finger-like piece would be the papillary process of the caudate lobe. So caudate lobe has 2 processes, caudate process and papillary process. If I know then that that is the right, this has to be right lateral, the right medial lobe. That makes this the quadrate lobe, and I know that because the gallbladder is, if an animal has one, is always located between the right medial and the quadrate lobe of the liver. Then we have left medial and a left lateral lobe. There are a number of ligaments associated with the liver that keep that liver tightly associated with the diaphragm. This is a very nice example here of what we refer to as a falciform ligament. The free edge of the falciform ligament, if I was to pull that out, is called the round ligament, and it is the remnant of what used to be the umbilical vein that was bringing oxygenated blood from the placenta, shunting through the liver to get into the caudal vena cava, and then ultimately to the right side of the heart and the fetus, and then ultimately through the aorta, and then back out the umbilical arteries and back to the placenta. So, falciform ligament is the large structure. The round ligament is the free edge. If I pull the diaphragm and hold it up like this, you can see this really nice ligament here, and that is the triangular ligament of the liver. And both right and left lateral lobes will have a triangular ligament, and it's nice and triangular shaped. So let's look and see if we can find the other one. And voila, there would be the other one. Last but not least, which is difficult to see, would be the coronary ligament, which is coming all the way around all of the hepatic portal veins and arteries as they're coming into the caudal vena cava. So right here would be the coronary, what we call the coronary ligament. So that's a good description of our diaphragm and our liver. Just to remind you, because I like this specimen very well. Now we can see that the stomach is behind the liver. So we have diaphragm, liver, and then stomach. And this is a stomach from a cat, and this is very nicely showing the lesser curvature of the stomach with the lesser omentum coming from the lesser curvature to the liver. Here all of this would be the greater curvature of the stomach, and what is sort of not still attached would be our greater omentum coming from the greater curvature, and then ultimately to the dorsal body wall. If we look at the stomach and divide it into regions, where the esophagus comes in more to the left side, we're going to have a cardia or cardiac region. This outpocketing, if I drew a sort of a straight line from there, anything to the left of that would be called the fundic or fundus region of the stomach. From there we go into the body of the stomach. You can see that it has a little bend in the stomach right there, and so approximately where my probe is lying, everything to the right of that would be the pylorus or pyloric region. The pyloric region can be divided into an antrum, which is sort of the larger part. Then it goes up into a canal, where it finally goes into the pylorus itself, which is the sphincter between the stomach and the descending duodenum, which is going to be located here on the right side. We can see really nicely too in this specimen the pancreas, in particular the right lobe of the pancreas in the mesoduodenum on the right side of the animal, and over here would be the left lobe of the pancreas, which was located in the deep leaf of the greater omentum. So it's left. As we come right over to the pyloric region, there's a small area that we refer to as the body, and then it goes to the right. So there, you can't really make a good demarcation between body, but left, body, right. I think that shows a lot about this specimen, and we have some other wet specimens available in the lab that you can look for these same things on.